So I'm going to assume that who's ever watching this video has walked through this lesson and they're still a little lost with it. So you really want to walk through it first before you watch this lesson. I'm not going to do all the show me's and everything. What we have there's two forms that have, well, there's actually more than two forms, but the two big forms for a quadratic equation is written this way. Y equals x minus h squared plus k. Now, if you think back, the parent function for a parabola or a quadratic equation is y equals x squared. That has a vertex at 0, 0. And then if you go over 1, if x equals 1, y equals 1. If x equals negative 1, y equals 1. If x equals 2, y equals 4. If x equals negative 2, y equals 4. And that's just making a table of values without table of values, right? And then you start transforming these. We can start shifting these left or right and then stretching them. So what you've got to remember, if they give us the equation in vertex form, this is the x coordinate of the vertex. And the k is the y coordinate of the vertex. So that's why if you think about this equation, x minus 0 squared plus 0, and then, so this vertex is 0, 0, so that's why I wrote that. I mean, why would you do that if it's 0? But you can. So this one here, find the vertex of that equation. Well, they walk you through this example of set it equal to 0 and solve for x. Well, that's really what you're doing. We're doing here. Let me get rid of some of this. What we're doing is we say when is that equal to 0, because we know normally the vertex is at x equals 0, right? X equals 0, 0, and y 0, 0. So where is that equal to 0? Well, we're going to add 5 to both sides. X equals 5. So you notice how it changes sign? So really, that's the shortcut way to do it. You can say, okay, so I know the vertex of this parabola is at 5, and then the 8 is the y value. You don't have to change that sign. So we have to change the sign for the x. We don't have to change the sign for the y. The reason we're going to change the sign for the x is because there's that minus sign in the formula. And if it happens, so like this. Let me move this up. Suppose I have this parabola, y equals x plus 3 squared minus 2. I know that this is shifted left 3, down 2, and then it doesn't have a stretch factor at all. So it'd be here and here, and then over 2, up 4, so it would be about here and here. So it looks something like that, right? See how that vertex is at negative 3, negative 2? See how I just changed the sign and kept that sign the same? So you don't have to do a lot of math with it. You just got to recognize what you're seeing. Okay, so that's vertex form. The other thing they talk about when you're graphing these parabolas or graphing quadratic equations, the x equals negative 3 is also, it's called the line of symmetry. So that's the point, that's the place where it's the fold. If you were to put a dotted vertical line through that point for this equation here, that's going to be on the vertex. So 1, 2, see how it's on the vertex? And then the y-intercept, the y-axis, the y coordinate of the vertex is just, you can see, oh, I knew it was going to be negative 2, but that way I knew where it was, right? I didn't have to do a lot of work with that. Okay, so x equals negative 3 is the line of symmetry. That's the fold place. If I folded that parabola in half along that line of symmetry, it would just look like I would just see one half of it, right? Wouldn't I see something like this, or depending on which way you folded it, right? I would just see that part. Okay, so that's another cool thing about that line of symmetry. Okay, so let me clear this up. Let me stop this video and take a look at this other example and see if we can't do a little bit more with it. So this is kind of blurry, but I think I can tell that the vertex is at 5, 8. I also see that it opens down. So I know that y equals, well, let's see, x minus 5 squared plus 8. But it opens down, and if you look at it, remember how we said at 0, 0, it goes over 1, up 1, over 1, up 1, goes over 2, up 4, because I'm squaring it. This looks like it's going over 1 and up 2, or down 2. That's because it opens. So, yeah, there's a stretch going on here. And there's a couple of ways to do this. Maybe the easiest way is to pick a point that's on the curve. And I think I'm seeing, what am I seeing? 6, 6? I think I'm seeing 6, 6. And you certainly, well, let me back up a minute. You could say, oh, it looks to me like it's going over 1, down 2. So I think that stretch factor is negative 2. And I'm actually right. But what happens is you don't have to do a guessing thing like that. You can actually find out what the equation is by writing out here. Let me do some erasing here. But there's some number a here that I don't know what it is, right? That's a, and I want to find out that a, and I've got this other point that's on the curve, 6, 6. So this is x, this is y. Let's substitute that into this equation and see if we can find out what a is. So 6 equals I don't know times 6 minus 1, or 6 minus 5, sorry, did you hear that answer, plus 8. So 6 minus 5 is 1. So doesn't that become 6 equals a times 1 plus 8? So then we got to do a little algebra, subtract 8, and lo and behold, a is negative 2. So that would be the equation of this parabola. Now we just have to stick the negative 2 in there. See, that's not too bad. So this next slide does just go into that whole axis of symmetry thing. Okay. So let's do some more with this example here. I mean, because you've already walked through all the lesson. Let's do some more with this. Let's write an equation for that parabola. I see a vertex of negative 3, negative 1. So that means that x equals negative 3, y equals negative 1. So y equals some number I don't know times x plus 3. Remember, it's minus a minus, minus 1. So we've got the vertex in there. I see a point that's on the curve. Let's do negative 2, 0. 0 is always nice to use. So 0 equals a times negative 2, because that's x for that point, plus 3 squared minus 1. I'll add 1. And then negative 2 plus 3 is 1. Square it, we get 1. So a is 1. So this is a nice, easy parabola. I don't have to do too much with this. No stretch factor. So I don't even need to write anything there. Now, the other thing they start talking about is writing these equations in standard form. So standard form is written in the form y equals ax squared plus bx plus c. So we've got to expand it out. So let's change this. Let's put this into standard form. Let's see, can I grab that and move that down? Come on. No, I guess I can grab the whole thing here. So I've got to write the x plus 3 times x plus 3 twice because I'm squaring it. The mistake that some people will do is they'll say it's x squared plus 9. They'll just square each of those things inside it. But, order of operations says raise to powers before we multiply, right? So you gotta take care of and then parentheses. So I've got to take care of what's in the parentheses, which means I'm squaring a parenthesis. I've got to multiply. So then we're going to FOIL it first, outside, inside, last. That's going to give me x squared plus 6x plus 9. Now I lost that negative 1. So I got to make sure I include it. So in standard form, this equation becomes x squared plus 6x plus 8. Okay? So there's that part. Now, the other thing that happens is, well, so we know the vertex, we know the standard form, we know vertex form. Sometimes they want to know, what's the y-intercept? Where does it cross the y-axis? Well, we could come back over here and look at the graph, see how it crosses is that. Oh my, it's a little blurry. I'm seeing 8. So I think it crosses at 0, 8. What we can do is, we can do it a couple of ways. Since I've already got this equation in standard form, here's f of x or y, right? Can't I just find what f of 0 is? Because that's where x equals 0, the y value will be the y-intercept. So 0 squared plus 6 times 0 plus 8. Well, that's all 0, and there's the 8. So it looks like the graph was right. I was able to read that graph correctly. You could go back and find the y-intercept here. If y equals the absolute value of 0 plus 3 squared minus 1, well, isn't that 3 squared minus 1, which is 9 minus 1 is also 8. So you don't have to have that expansion done. That's that. The last thing they talk about here is to find, well, I think they've talked about it, is that they need you to find the x-intercepts. Where does it cross the x-axis? So when we're looking for y-intercepts, we know y equals 0. But when we're looking for x-intercepts, right? When we're looking for x-intercepts, hey, let's come back and look at that graph. Let's see if I can drag it back over here. And let's delete this. See what the x-intercepts are? They're right there, right there, and right there. I don't know, that yellow is showing up. And y is equal to 0. See how in the point each of the y's are equal to 0? So when we're given the equation and we have to find out where, let's see, where am I? Here. What I'm going to do is I'm going to solve the equation 0 equals x squared plus 6x plus 8. You see how I brought that down? So how does that work? Well, let's see. I should probably try to factor. It's a quadratic equation set equal to 0. So what multiplies to give me x squared? Well, x times x. What are the factors of 8, which will add to 6? Well, factors of 8 are 8 and 1 and 2 and 4. Do you see how the 2 plus 4 is the 6? And because everything's positive, both of these are positive. So this crosses the x-axis. So then what you do, what happens if x equals, I'm getting ahead of myself. I'm sorry, back up here a minute. X plus 2 equals 0. Because if x equals negative 2, this whole expression 0. It would be negative 2 plus 2 times negative 2 plus 4. Well, that's 0, so it doesn't really matter what this is. The whole expression is 0. That's that zero product property you might have heard about at some point in time. So x equals negative 2 is a 0. The other 0 is x. Where does x plus 4 equal 0? Well, that's at x equals negative 4. So we know we've got the two x-intercepts, negative 2, 0, and negative 4, 0. Of course, we saw that on the graph, but that's just how you do it algebraically. That's one way to do it. I guess let's go to the next slide because they have some another example. Okay, so we're going to do this step by step and address each one of these elements, okay? So to find the axis of symmetry, we need to remember we're going to use this formula, x equals negative b over 2a. And that's when the quadratic equation is in the form ax squared plus bx plus c. So for this equation, I see 1x squared plus 8x plus 12. So a equals 1, b equals 8. So to find the axis of symmetry, this is the vertical line that goes through the vertex. I'm doing negative 8 over 2 times 1. So that works out to be negative 4. So x equals negative 4 is the vertical line that this parabola has a vertex on. So 1, 2, 3, 4. There's that vertical line. Now, in order to find the vertex, so we know where on that line it falls, what we're going to do is we're going to find f of negative 4, and that'll tell me the y. Because remember, f of x is the same as y. So if we replace all the x's in the equation with negative 4, that'll tell me what y is. So negative 4 squared plus 8 times negative 4 plus 12, well, that's going to be 16 minus 8 times negative 4 is, what, negative 32 plus 12. And so 16 minus 32 is negative 32, plus 12 is going to be negative 20. So the vertex of this parabola is negative 4, negative 20. Now, how does that graph? Well, let's see. At least to get it started, what I can do, I know that's not, this will help us with some of the later values here. I do know that this vertex, the line of symmetry was at negative 4. And then this graph, I'm not going to draw this to scale. I know the y-coordinate is way down here at negative 20. So negative 4 and negative 20. And then it moves up this way somehow. I know it moves up because it opens up, because that original equation was positive x squared. Wasn't it plus 8? X plus 12. So I know it opens up, so that's the lowest it's going to be. Okay. Now the domain is what x values can I substitute into this polynomial or into this function. Now with a polynomial, that works out to be all x's or any x, because I'm not, the only thing I got to worry about is the square root of a negative number, or when I'm dividing by 0. And this function doesn't have either one of those problems in cases going on. So, well, there's other situations, but we're not there yet, so let's not worry about these. These are the two things you've seen. So the domain is going to be all reals. Now, how about the range? So do you remember how when I said just a second ago, I know that this graph, this function, has a vertex of negative 4, negative 20, and then it opens up. So the lowest this function ever goes on the y is negative 20. So that point is negative 4 and negative 20. So the range will be y has to be greater than or equal to negative 20. That's the nice thing about knowing the vertex. Okay. Next piece. So the y-intercept is a point where x equals 0 and y is some number, right? So if you think about that graph that I had a minute ago, 1, 2, 3, 4, 1, 2, 3, 4, way down here at negative 20, whatever that is. So I know it looks like that, and it opens up. And boy, I would love to know where it crosses the y-axis. That would give me another point to graph. So I got the vertex, and I have another point. If x equals 0, all I have to do is evaluate that function at x equals 0. So 0 squared plus 8 times 0 plus 12. Well, that's 0, that's 0. That means that point right there is 0, 12. I know it doesn't look like that on the scale, but that's where it is. So that's the y-intercept. So to find the x-intercepts, I want to know, now again, my scale is probably not right, so we won't worry too much about that right now. I'm looking for where does it cross the x-axis. And at each of those points, whatever those points are, I know y is equal to 0. So what I'm going to do is find out where this function equals 0. So I'm going to write 0 equals x squared plus 8x plus 12. Now, unfortunately, this isn't as easy as finding the y-intercept because this is a quadratic equation, so we have to factor it. So what you got to remember from that is, what can I multiply to get x squared? Well, x times x is x squared. Factoring, remember, is unfoiling. And then I'm going to ask myself, what can I multiply to get 12? Well, 1 times 12, 2 times 6, 3 times 4. And then whatever I put here and whatever I put here needs to get added together to get 8. And I hope you see there's the 2 and the 6. So I'm going to write 2 here, 6 here. I could reverse it. It wouldn't matter in this problem. And because I want a positive 12, either both of these are negative or both of these are positive. And because that's positive, I know they're both positive. Okay. And then we're going to use that zero product property that says, where does x plus 2 equal 0? Well, subtract 2 from both sides. X equals negative 2. Where does x plus 6, here, let me undo what I just started to write. X plus 6 equals 0. So subtract 6, x equals negative 6. So my x-intercepts are negative 6, 0, and negative 2, 0. And as you can see, my scale is certainly off in this graph. Okay. But that's where it would be. And it makes sense that those are both negative looking at my graph. So, and what do we want to do? And I guess that's it. The only thing I haven't done is write this equation in vertex form. So why don't I do that? I know the vertex of this parabola is negative 4 and negative 20. I know the leading term has a coefficient of 1. So if vertex form is y equals a times x minus h squared plus k, and I know this is h and this is k, I can say y equals 1 if you want. X plus 4, because it's minus a negative 4, right, squared, minus 20. So that's in vertex form. And that's all there really is to this. Give a yell if you need some help.